Okay, today's topic would be Hibernate association mapping, many to many, bidirectional with join table. Yeah, that's the topic today. And see, we are seeing many to many Hibernate association mapping. So directly we'll go to bidirectional mapping, since unidirectional will never be used. So when you are developing projects and all, no? So always we create the entities which are bidirectional only. So straight away we'll switch on to bidirectional. Yeah. So to understand what is many to many, I'll give you an example now. Example for many to many would be one employee is working in many projects. That's an example. And one project will have what? Many employees. Like that. That's one example. Now, but the example what I'll be taking is, see this is also a good one. One student will do multiple courses, many courses, and one course will have what? Many students. So these are some of the examples of what? Many to many. So the subject is many to many, okay. But what you have to understand is, applying many to many is nothing but what? Applying one to many on both the sides. If you apply one to many on both the sides, automatically it becomes what? Many to many. That's the key concept here. So for both the entities, if you apply one to many, automatically it becomes many to many bidirectional. Means you'll use set here also, you'll use set here also. That's the concept here. So yes, before we move into this example, let's see the one database design and the scenario now. Clear? And then we'll go into entities and the design of the entities and all. A very simple design now. See, we are having, what is the requirement we are having now? One student can join for many courses. One course will have many students. So let us see the design of the tables for this scenario. Do not look into the entities. First look into the design of the tables, because based on tables we'll be creating the entities. Always remember this. So we have to understand the design of the tables. So yes, we are having one table here called as student, and one more table is there called as course. There are two tables. So in the student table there are two columns, SID and SName. There are two columns, and in the course table there are two columns called as CID and CName. So in the student table, see, there is some test data I filled. SID is 1, means the student ID is 1, and the student name is Ravi. And one more student 2, his student name is Kumar. So two people are there, and these are the different courses available now. Which are there? One is Java, 2 is JSP, 3 is Solid. Like this, some courses are there. Fine. So these are the two tables. So now see, whenever we have a many to many, so it becomes impossible to relate these two tables. So this goes into the design of the tables. You should be strong in database for this. Understood? You should be very strong in database for this. What you have to understand is, whenever you are having many to many, you cannot relate these two tables. So when you cannot relate these two tables, means you cannot keep a foreign key in this table also. That's what I am trying to say. You cannot relate the tables means you cannot keep the foreign key in course also, or you cannot keep the foreign key in student also. So that is why what we do, we move the relationship to another table, one more third table. Okay, so the relationship of these two tables will be maintained in one more third table called as join table. So here the relationship will be maintained now. So this is the third table what you are seeing. And what is the name of this table? You can give any name. I have given the name as student course, and this is called as join table. So this is purely DBMS design, RDBMS design. So in database, when we are having many to many, this is how you are going to design the tables. Three tables you will be having when you want to implement many to many. Yeah. So now three tables you will be having, and now again, if you want, you can check the test data here. In the third table, see how you are maintaining the relationship between the two tables. Student ID is 1. He is joined for which course? 1. That is Java. Student ID is 1. He is joined for which course again? 2. That is JSP. Again 1 has joined for 3, means Solid. So student 1 has joined for all the 3 courses. Similarly, student 2, that is Kumar, has joined for what? All the 3 courses. So clear this? So this is the design of your tables. Yeah. So next, the scenario will bring now. The scenario, that's the design of the table. The scenario is very simple now. If you enter student ID, if you enter the student ID, what should happen now? You should connect to the database. You're going to submit. This is the scenario now. Okay, so your application should, what it should do? It should connect to the database now. So this will be the request and this will be the response of your application. Means you are going to enter the ID. This is your application. Your application should interact with the database, fetch all the values, and it should display here. Okay, like example, if I enter the ID as 1, student ID as 1, what should be the display? Student name is Ravi and his list of courses. What all he has joined for? Following are the courses Ravi has joined for. It would be Java, Servlet and JSP. So it should display like this. Following now? So supposingly, this is one scenario I am giving. One more scenario now. If I give the course ID, who all have joined for course number 1, it should give you that list also. Means, now what is the scenario? Ulta it is. You are entering the course ID. So course name, what will be course name now? Java. So who all have joined for that course? Ravi and Kumar. Following students have joined for this particular course. So we understood the design of the tables. I have given you the scenario also now. Okay, now we have to understand for this design of the table and for this particular scenario, how will you create your entities on TO? Clear? So this is what you have to understand now. So now we have got 3 tables. Yes, but we are going to create only 2 entities. We are going to create only 2 entities. What are the 2 entities? One is the student entity and the other one is the course entity. And look how you will do it now. So in student you will have 3 properties, SID, SName now. And these 2 properties will be mapped with these 2 columns. Okay. And in course you will have CID and CName. These 2 properties will be mapped with what? These 2 columns. But here what you have to understand is the set of courses, this property is mapped with CID column and the set of students will be mapped with SID column. Clear? And see, it is association mapping what we are saying. Cardinality is many to many. Cardinality is many to many. Direction is bidirection. Clear? Association mapping means student has a course, course has a student. It is association mapping what we are saying. So association mapping, cardinality is many to many, direction is bidirection. And if you want to do many to many bidirection, you have to use what? Mandatorily join table. Means don't see from the Java point of view, see from the RDBMS database point of view. You have to create 3 tables like this. Then only you can relate these 2 tables. So whenever you are having many to many, you cannot maintain the relationship of both the tables in the any of these 2 tables. So we maintain the relationship of these 2 tables in a 3rd table called as join table. Clear? So this is the whole concept now. So we have understood the concept now. So only we have to see now how it will be implemented with Hibernate. Clear? Before we move to the example, you write some points on this. Many to many, unidirectional and bidirectional. We are going with many to many now. Many to many unidirectional mapping. I have really clearly written it. Since we always do bidirectional mapping, we'll focus on bidirectional mapping only. Yeah? Because nobody will do unidirectional in projects. Practical point of view, nobody will do unidirectional mapping. Because you'll be wasting entities. Clear? So that's the reason we do bidirectional. Fine, next. Many to many bidirectional mapping. This is the topic what we are saying now. Applying many to many relationship between 2 entities is nothing but what? Applying one to many relationship on both the sides. Both the sides you are using what? Set. So student has many course. So one to many. Same way one course has many students. From that side it is one to many. So that is how it goes now. Clear? So that's what is the meaning of the statement. Applying many to many relationship between 2 entities is nothing but applying one to many relationship on both the sides. It means in both the mapping files you'll use what now? Set. That set tag you'll use, and you'll be doing what? One to many. So in student.hvm.xml also you'll say set one to many. In course.hvm.xml file also you'll say set one to many. That's it. Very simple. So fine. Now example what I am taking is one student is doing many courses. One course is having many students. So that's what? One to many. Again one to many. Now to create this relationship you need to have a student table, course table and a third table called a join table. When there is many to many relationship, we move away the relationship to another or third table which is called as join table. In many to many relationship, join table contains only foreign keys, nothing else it will contain. Just both the foreign keys it will be containing. SID as well as CID, both were foreign keys. Done? So we'll store that. Yes, now we'll come to the example. Yeah, see we are going to the 19th example now. This is the 19th example. Clearly says 19th and 20th. I'll be showing you two examples. One with XML configuration, other one is annotation configuration. So 19th one we are going, 19th association mapping, many to many bidirectional XML. So first straight away we'll go into the design of the entities. You understood the tables, three tables you understood. So let's go into the design of the entities. So student has got many courses. Yes or no? Student has got many courses. So set of courses. We are using generics. Clear? Similarly this side, course has many students. So both the sides set, and you know how to do the mapping of set. Very simple now. So let's go with the mapping files. I'll open student.hvm.xml. Very simple. Yes, what are the properties? SID is on properties. Yes. Student entity is mapped with student table. Student entity is mapped with student table. That is clear. Three tables are there. Carefully concentrate. SID is mapped with what? SID column in student. Yeah, SID is mapped with SID column in student. Similarly, SName is mapped with what? SName. So two properties over SID and SName. The most important is what? Set of courses means student courses property is there now. See how it is going to be mapped now. Set name courses. Table is which one? Student course. The third table, joint table. Yeah, inverse is equal to false, cascade is equal to all. Fine. Column name is SID, but see this many to many I am using. The tag what we are using is many to many. Remember this tag now. Many to many. Entity name com.cluster dot and column name is what? CID. So finally what is happening? Courses is getting mapped with CID. That's it. Are you clear? And this side, same thing. In course.hvm.xml, what is happening? Set tag. See, this is the entity. It's mapped with course table, and CID is there. Is mapped with CID column. CName is mapped with CName column. Again, set of students is mapped with what? SID column. That's the foreign key column. So two tags you have to use here, key and many to many. Two tags you have to use, but this is the main one now. So students will be mapped with SID column. So that's it. So if you do this much, your mapping is done now. Set tag you have to use and the mapping will be done. So once it is done, next is what? Entity is ready, mapping file ready. Only what we have to do is configuration file you have to register. What? The two mapping files. So everything ready. Now we have to see the create the table and run the client code. Very simple. So let's see this. Tables.sql will go. Okay. I'll copy the script. So I'll be using MySQL. I'll paste the script and run the queries. Fine. So now let's see. We can see select star from student. No records. Select star from course. No records. Select star from the third table. Student course. There are three tables. There is no data. Student also no data, course also no data, student course also no data. and you can see this is the script. Drop table student course, drop table student, drop table course, create the one table student table, create the course table, and create your student course table. Okay, and here you will be referencing. See, in the student course you are referencing what? Student ID and course ID. Clear? So the tables are ready, 3 tables. So once this is ready, next we have to discuss about the client code. Tables ready, entities ready, mapping done, configuration done. Only client code has to be discussed now. So see here, course C1 is equal to new course. Course seat means it is Java, set name, course 2 Servlet, course 3 JSP. Fine, 3 courses are there. Then next, 2 students, student S1, student S2. Fine. Now see, SC, this is a set of courses. So this one set, where we'll add all the courses. So in this set I am adding course 1, course 2, course 3. Fine. Means we are preparing one set. And then next, one more set is there. Set of what? Students. So this set will contain all the students. So 2 sets are there. One is SC, which will contain all the courses, and other set is containing all the students. Now we'll associate. What will you do? So for the course 1, I'll add the set of students. Both the people are doing both the 3 courses. Ravi and Kumar are doing what? All the 3 courses. So for C1 I added the 2 students, means I added the set. For C2 also I added the 2 students. For C3 also I added the 2 students. Similarly, in the students I am adding what? Courses. I am associating. So just go through the associating course with student. Once you do the association, now I have tried the Hibernate client code. Yes, this is normal now. From the Hibernate util I'll get the session factory. I'll open session, I'll get the transaction, and I'll just say save now. That's it. So when I say save, it will insert the records into database now. So fine, we are going to say save now, session.save. I'll save both the students, S1 and S2. This data has been stored now, clear, in all the 3 tables. So select from student course, means what? 1, 1, 1. Where is 1? Ravi is doing the 3 course, 2, 2, 2 is also doing all the 3 courses. Yes, we'll see students now. Ravi has joined for all the 3 courses. One more table you have to see, course. Clear? So the data has been filled into all the 3 tables. So we have understood how to save now. Now let's see how to read the data from the 3 tables. So I'll use these 2 entities now. Yes, it is bidirectional. So since it is bidirectional, what happens? Student can access course. Yes, so I load the student and I can get all his course information, what all courses he has joined for. So you see this, I will get the ID, I will get the name, but if I say s.get courses, it's a set of course. And I am using the for loop, enhanced for loop, and I'll print all the courses. So see this. Student 1 has joined for how many courses? C. He joined for all the 3 courses. Ravi has joined for Servlet, Java as well as JSP. Clear? And next, course can also access what? Student. So for the course, the first course who has joined, let us see now. Course ID number 1. Both of them have joined now. Kumar as well as Ravi have joined for JSP. That's the first course. Clear? So this is what? Many to many bidirectional. Clear? Yes, you understood the concept now. Only we have to see now how to do the configuration with what? Annotations, nothing else. Very simple. So we'll not have the mapping file here. We'll do the configuration in the Java file itself. So we'll open student and open course. So in student, say this all you know now. Entity, table, okay. This is an entity, it will be mapped with student table, student entity is mapped with student table, ID column, you know this, column you know, S name, that is okay. But most important is this one, get courses, means on course you have to do the mapping. Now see how you are doing, many to many annotation we are using. Cascade is equal to cascade type all, and at the rate of join table, two annotations you are using. But look, name is equal to student course, this is where you are specifying the third table, that's the join table. Student course is a join table. Join columns is equal to, so it's an array of annotation, you are providing the values. At the rate of join columns, name is equal to, means attribute is actually join columns. Till now you are using this join columns, but this time I am giving the value as array. It's an array now, array of annotations. Array of join columns, name is equal to SID, inverse join columns is equal to, at the rate of join column, name is equal to CID. If you do this much, which one? Student will be mapped with the third table, that is join table. One more, this side course, what we have to do? This all same. We'll use many to many only, but mapped by courses, cascade is equal to cascade type dot all. So if you use this side one annotation, it is sufficient. Result is same now. You already seen the output. Clear? So just show you. So these two entities with annotations, what you have to do? Register in or specify the location of these two entities in the configuration file by saying what? Mapping class is equal to. So specify it. So then next you can open demo.java, client code is same, there is no change. Okay, only I have to drop the tables and recreate the tables now. So I'll do it. Now these are the tables. Done. So all the tables have got created. These are the tables what we have created now, dropped and created. So now only we have to run the client code. Same thing, creating 3 courses, creating 2 students, then we are creating the set of all the courses, then we are creating the set of all students, then associating student with course, next associating course with student, and then I'll say both the students. Same client code, there is no change. So done. Data will be inserted, select star from student. Right now there is data, so then course, yes I got the data, student, there is data. So it has inserted into both the tables. So only what we have to do is now try to read the data bidirectionally. Same thing, if I load the student, I can get his course details. Done. Student 1 has joined for Servlet, JSP and Java. And for course ID number 1, correct? This is what course can access all the students. So for course ID 1, Ravi and Kumar have been enrolled. So this is what is many to many bidirectional mapping. Clear? Okay, that's it about many to many bidirectional mapping.